Hi, Integrated Math 1. Welcome to lesson 2.4.2a. We're going to be exploring area and perimeter of triangles and rectangles on the coordinate plane. So you guys have gotten really good now at using distance formula, figure out the lengths of sides of triangles, rectangles, various things on the coordinate plane. So now we're going to use them to help us find the area and perimeter of our triangles and rectangles on the coordinate plane. So today, we're just doing the first part of this we are on page M2-267, if you're not sure where we've gone. So you're going to determine the perimeter and area of rectangles on the coordinate plane, and of course, determine the perimeter and area of triangles on the coordinate plane. You've used the distance formula and the slope formula to classify your geometric figures on the coordinate plane. So how can you use these same formulas to determine the perimeter and area of rectangles and triangles on the coordinate plane? So previously we've classified them by examining the lengths and the relationships of their sides. Are they parallel, are they perpendicular, that kind of a thing. Now you will determine the perimeter and area of those figures. I do want us to take just a few notes. We're on page 269, and we are going to work on the problems on that page. But just up above where you have a little bit of space, I do want us to take just a few notes. So just a reminder, perimeter is around the outside. That's the distance, and actually maybe I should put it that way. Maybe that'll make it better. Oh, there we go. So perimeter is the distance around, and sorry, my pen went weird. And generally that means add all the sides, right? Add all the sides, right? That's what we do. Area is how much fits inside. So perimeter is the distance around, and generally we add up all the sides to do that. Area is how much we can fit inside the figure. So we are dealing mainly with rectangles and triangles. So we're going to talk about both of these for just a moment, rectangles and triangles. And we are talking about perimeter and area for each of these. Let's start with perimeter here. A perimeter of a rectangle is the distance around. And it seems like on an earlier lesson last semester that we talked about how to find the perimeter of a rectangle, that you could just add up all four sides, length plus width plus length plus width. But a lot of you guys realized, well, the two lengths are the same, the two widths are the same. So a lot of you guys realized that instead of length plus width plus length plus width, you could write double the length plus double the width. And that was just an easier way of writing it. For triangles, we don't have that luxury. We have been referring to the sides of a triangle as A, B, and C, and you just have to add them together. There's no nice cutesy formula for that. You just have to add the three sides of a triangle together to get the perimeter. Now, area is how much it fits inside, and if you recall, if you're taking it back a ways, area, you just do length times width, right? Again, we're taking it back to like 6th and 7th grade. Or often instead of length times width, I prefer to say that the area is base times height. And you'll see why, and later on, why I prefer that. For a triangle, it also is base times height. But remember, a triangle is like a parallelogram that got sliced in half. So we say it's 1/2 base times height for the area of a triangle. So you want these formulas, you need these formulas. I really recommend that you write these formulas down somewhere because they are about to become super, super duper handy for what we're about to do. So knowing these formulas now, knowing all this junk, knowing what a perimeter is, what an area is, I would like you to go to question number 1 on page M2-269. And I want you to do two things. I want you to do part A. I want you to determine the perimeter of rectangle ABCD. And then I don't have it on my screen, but I also want you to do part B, determine the area of rectangle ABCD. So go ahead, hit pause, work these out, hit play when you're ready to check your work. You ready? So we said perimeter was length times width, double the length, sorry. Length Double the length plus double the width. I'll get there. So real quick, let's figure out how long these are. Now, this rectangle is very convenient because it's right on the grid lines. So you can just count, right? 1, 2, 3, 4, 5, 6. So it looks like my length here is 6. And my width, well, let's see. 1, 2. Looks like my width is 2. So I can do perimeter equals twice the length, 6, plus twice the width, which is 2. And use a calculator. It's always helpful. 2 times 6 is, of course, 12. 2 times 2 is 4. If I add those together, I get 16. So the distance around my rectangle is 16 units. But I also asked you to do part B. I'm going to put my 6 and my 2 back here. I also asked you to do part B, which is find the area. We said area was length times width, or I preferred base times height, and we can see my base is 6, my height is 2. So 6 times 2, which is, of course, 12. So that means I can fit 12 square units inside of my rectangle. That's pretty good. Now, this was all fine and good because the sides of the rectangle were on the grid lines, but we know that's not always going to happen. When the sides of a rectangle do not lie on the grid lines, and this is big, the sides aren't on the grid lines. I don't know how long that side is. I can't just count anymore. You can use the distance formula to determine the lengths of the sides. So if you're like, I don't know what the length is, I don't know what the width is, or I don't know what the base is, I don't know what the height is, use the distance formula and you can find it. So with that in mind, I would like you to find the perimeter and area of this lovely quadrilateral. You do want to round your answer to the nearest hundredth. Notice it's the hundredths this time, not the tenths. That's the book speaking, not me. That does mean you're going to want to start by writing down the coordinates of the points and then using the distance formula, and then you'll have your base and your height and your length and your width, and you'll be able to find the perimeter and area of your quadrilateral. So go ahead, hit pause to work this out, hit play when you're ready to check your work. So I do need the coordinates. Do be careful. I noticed on the graph that it was counting by twos, so watch out for that. So that means the coordinates for L are at -8, -4. Oh, I guess we're counting by twos here and we're counting by fours there. Wow, they made this hard. It looks like the coordinates for L are at -8. I had to go over 8, -8, and then down 4, so -4. Coordinates for O are at 4 to the right, and oh gosh, that's like, how far down is that? It's like -10. 8, 10, 12. Yeah, that works. The coordinates for N, it looks like we're at -8, and then we went all the way down to -16. And then the coordinates for M, it looks like we went all the way over to -20, and then down to -10. Can I tell you a secret? Because this is a quadrilateral, I don't need all 4 sides. I just need 2 of them. That's right. I just need to do the distance formula twice. If I'm like, hey, that's my base, hey, that's my height, I can just do the distance formula twice. Makes this so much easier. It does. So I'm going to do that. So the base of the NO, let's work on NO because I'm like, that's my base. So NO, I know I have a big square roof. You remember your distance formula. Remember our distance formula, and we subtract in the distance formula. My x coordinates, if I'm using these guys, are 4 and -8, so 4 minus a -8. Sorry for my weird pen. My y coordinates are -10 and -16, so -10 and a -16. Double negatives become pluses, so keep that in mind. So that means I have 4 plus 8, which is 12 squared, plus -10 plus -10 plus 16, which is 6 squared. If I use my calculator, I have, what do I have? 144 plus 36. And thank you, Mr. Calculator. 144 plus 36 is, of course, 180. Now I'm going to leave it like this for now. I'm just going to leave it at 180, square root of 180. I could round to the nearest hundredth, and we will, but I'm not going to worry about it just yet. Let's find the other side. Let's find side LO, because then I'll have my length and my width, or my base and my height. And again, we'll subtract our x coordinates, so -8 minus 4. We'll subtract our y coordinates, -4 minus, oh, badness, Scott. I'm going to fix that. -4 minus a -10. -8 minus 4 is a -12. -4, ooh, that becomes a plus, right? That becomes a plus. So -4 plus 10 becomes 6. And again, sorry, my pen is being weird. This looks familiar. -12 squared is a positive 144. -12 times a -12. 6 squared is 36. And once again, we have the square root of 180. Now, I could grab a calculator and do decimals, but I'm going to hold off. I'm going to hold off for just a minute, okay? I'm going to hold off for just a minute. So I'm going to grab another color. I like purple. So I'm going to grab another color. And let's start with that perimeter. Twice the length, which is a square root of 180, plus twice the width, which is square root of 180. And thank goodness I have a calculator. All right, what is the square root of 180? Looks like I got like 13.42 or something like that. And if I double that, because I'm multiplying by 2, I get like 26.83-ish, because I didn't remove it from my calculator. I didn't want to round early, so I kept it there. Oh, but I got to double it again because they're the same. I'm adding it to itself. And again, I'm keeping things in my calculator. I don't want to round early. That never ends well. Turns out I get about 56. I can't write. Oh my goodness. Try that again. 53.67, roughly. So there's my perimeter. I'm going to grab another color to give me some space to do my area. Area is easier. And let me show you why. So area is just length times width. So I'm going to do the square root of 180 times the square root of 180. Do you want to know a cool trick about square roots? You can actually, if they're being multiplied, you can multiply this stuff inside before you do the square root. Did you know that? So I can do 180 times 180. And so I end up with the square root of 32,400, because I can just multiply those together since they're being multiplied. And if I do the square root of that, hey, I got 180. What? All right. Sorry, I got a little crazy, mainly because my pen went nuts. But you get the idea. I didn't have to do distance formula all 4 times. I just needed to do it twice. I needed to find the length, I needed to find the width, and then I had what I needed. Now, it did get messy with the decimals, and that's why we have calculators, and that's okay. You'll notice I kept things in my calculator and waited to round until the very, very end. It makes it easier that way. All right, I'm going to come on over here to what's next. Ooh, I have a triangle. I think you can do this now. I think you don't need me anymore. And by the way, I did give you the vertices up here, so that makes it a bit nicer. I think you can do this. So go ahead, hit pause, find the perimeter, find the area of triangle DEF. And remember, you may need to use some distance formula to help you find those lengths. So go ahead and hit pause, work this out, and then hit play when you're ready to check your work. You ready? How'd you do? So first of all, I needed to find all the lengths. So I realized that for DE and EF, I could just count them. Please notice the graph is counting by 2s. Did you catch that? So when I counted, it's 2. Oh, actually, I'm going to grab my red pen here. It's 2, 4, 6, 8, 10. So that's actually a length of 10 right there. It's a height of 10. And that means when I count across here, again, I'm counting by 2. So 2, 4, 6, 8, 10, 12, 14. So it's 14 across there. Now, in order to find perimeter, I need to add up all 3 sides. I am missing a side. We need to find the side length of side DF. And this is where I have to use the distance formula, because I don't know how long that is. I can't just count it. When it's vertical or horizontal, I can just count it. I can't do that when it's slanted. I have to use the distance formula. So I'm going to use distance formula, and we'll use points D and F. So X, Y, and F over here is X, Y. So let's do this. My X's are -9 minus a -2, square it. Plus, got to subtract my Y's, -4 minus a -14, square it. Of course, double negatives become pluses, so that's convenient. And let's see, -9 plus 2 is -7. -4 plus 14 becomes 10. -7 squared is 49, because a -7 times a -7 is a positive 49, and 10 times 10 is 100. So it looks like I have the square root of 149. Now, I'm going to need to do the decimal soon, and I will do the decimal, but I'm going to hold off on it. There's no rush on getting a decimal for this. So let's go ahead, and again, I'm going to grab some other colors just to make it easier. I'm going to use a blue this time. So let's find the perimeter. For the perimeter, I just need to add up all 3 sides. So 10 plus 14 plus the square root of 149. Now, if you have a nice calculator, like one of those really nice TIs, Texas Instrument calculators, actually some of the nicer Casios will do this as well. You can just type it in the way you see it. It'll spit out an answer for you. I have an older Casio. It's not as fancy. So I actually do need to do the square root of 149 and figure out that that's about 12.21. So it looks like I've got 10 plus 14 plus 12.21, and I will add these all together. And it looks like I get a perimeter of about 36.21. Hooray! And let's go ahead and let's find the area then. Okay, remember in a triangle, area is 1/2 base times height. Take a look at what we've got here. Please remember that the base and the height need to be perpendicular to each other. That's going to become important in the next lesson. Watch out. So my base, it looks like it's 14. And it looks like my height is 10. Again, sorry for my pen being weird. We know it does that sometimes. And yeah, I'm going to use my calculator. 14 times 10 is, of course, 140. And if I cut that in half, if I divide that by 2, oh dear, it helps if I hit the right buttons, doesn't it? If I divide that by 2, I get an area of 70. So it's going to be 36.21 units to get around my triangle, but I can fit 70 square units inside of my triangle, which is kind of snazzy. I like that. It really is nice when one of the sides lines up with the grid lines, and I recommend taking advantage of that whenever you can. If it doesn't line up with the grid lines, no big deal. We'll just use distance formula. It's just going to take a little more time. And that's okay. We can do that. It's just more time consuming. As always, guys, I hope you found this helpful. Hope you found it useful. If you got questions, concerns, talk to me. I'll see what I can do for you. And I'll see you guys soon. Bye.